कि mass spectroscopy के अंदर आपको क्या क्या information मिलती है, लेकिन हम सिर्फ molecular ion peaks को ना उनको discuss कर रहे थे, ठीक है। बाकी peaks को हमने molecular ion peaks वो होती थी जो सबसे बड़ी peaks होती थी। For example, CH2Cl Br का जो ion बनेगा ना, that would have different peaks, और हम सिर्फ उनके ऊपर we were only focusing on them. Now what we're going to try and do is we're going to talk about fragments. कि a lot of information could be extracted from fragments. क्योंकि the problem is कि isotopes are not very abundant for other elements. मतलब इधर तो ठीक है कि because of chlorine you'll be getting different peaks because the masses would be different, because chlorine has a lot of abundant isotopes. Chlorine can be 35, it could also be 37. Similarly, bromine has abundant isotopes. Bromine could be 79, it could be 81. So you would get different masses for the molecular ion. Okay, sometimes this molecule would have a mass of 84. Sometimes it's going to have a mass of 86. There would be two different particles having the same formula. Because Br has two isotopes. So which is why you were getting different probabilities for different peaks. Okay, carbon isotopes, although were not very they're not very abundant. But carbon also has an isotope which is 13, and it has a very tiny probability of 1.1%. And there are chances that you might get carbon 13. So if a CH4 molecule, most of the time it's going to have a mass of 16, because carbon is 12. The probability is 99%. But there could be chances that one of the carbon is 13. So you could get a mass of 17, but the probability of that is very low. But we learned that you can figure out the number of carbon atoms by comparing the M and M plus 1 peak. For example, in a C2H6 molecule, you're going to have a mass of 30. This ion is going to have a mass of 30, but it could also have a mass of 31. Okay, if one of the carbon is 13, and it could also have a mass of 32. लेकिन M plus 1 से आगे वाली जो peaks है ना, the probability decreases a lot. Getting two carbon 13s is almost impossible. 0.0121%. That's very, very low probability. That's 10 times. I mean, it's even less than 1%. It's 10 times less than 1%. Not even 10 times. It's actually 100 times less than 1%. Acha, so you would only talk about M and M plus 1 ratios. And by looking at the ratios, you could figure out how many carbon atoms are present in a molecule. Now, the next thing we wanted to discuss was, okay, I wanted to discuss fragments. Okay, how we hadn't mentioned or talked about fragments, but how would fragments help us in figuring out the structure of the molecule? Okay, that's the first thing. Fragments, they help to figure out the structure of a molecule. Okay, they help you to figure out okay, which atom is bonded to which atom, uh, what are the structures in the molecule. These can be understood by examining the fragments. For example, you have a molecule of carboxylic acid, which is CH3, serial bond O, and OH. When it gets ionized, this is ethanoic acid. When it gets ionized, you're definitely going to get a molecular ion, which is going to be CH3, COOH, and it will have a charge of +1. So that's your uh, molecular ion, and it will have a mass of 46. I think it will have a mass of 46. It's going to be 45. I mean, this is 45. 32 plus 13 is 45. Plus, I mean, this has a mass of 60. This will be the heaviest particle that's going to be detected. But you're going to get a lot of tiny fragments. Tiny fragments, किस तरह के the molecule would break down into small, very tiny pieces. It would break down here. So you might get a fragment of OH plus 1. That might get detected. The other part would be CH3CO plus 1. That might get detected. You might have a fragment of just the CO in the middle, that might be obtained, or a CH3 plus one could be obtained. So all sorts of fragments. Even I said now the thing is the fragments that are obtained are always a part of the original molecule. For example, CH2 plus one could be obtained. You could have a fragment of CH2CO plus one as well. Okay, so any piece of the original molecule might break away and can be detected. Like this piece could be detected. That's a possibility. So all sorts of fragments can be detected. Uh, so you would have when you do mass spectroscopy, and remember the fragmentation pattern is mostly completely random because you don't know how the molecule would break into smaller pieces. So you would have a particle that would not be deflected a lot. That's the molecular ion. That would be the M. That would be having a mass of 60. And then you would have hundreds of these tiny fragments, each deflecting. If it's lighter, it's going to be deflected more. If it's heavier, it's going to be deflected less. So lots and lots of fragments are obtained. यहाँ तक is this clear? Sara, is this clear? Aisha, clear है?
Yes, sir.
ठीक है.
Yes, sir.
अच्छा, so how do the fragments help you in figuring out the structure? So for example, let's start with a simple question. The question states that there's a gas X that is forming and it undergoes mass spectroscopy. So I'll do a question. And they say that different fragments are detected, or you can say uh, there are detections at mass to charge ratio. You're detecting something at 14. There is detection at 16 as well. Then you're getting something at, and I can make a graph actually. So you're detecting something. I mean, there's some detection that's happening at 14. Some particle is getting detected at having a mass of 16. Then you're getting something at 28. Then you're getting something at 30 as well. And then you finally you're getting something at 46. I think it's 46. One second. Yes, nee, 44. One second. Yeah, 44. So you're getting all these detections at different masses. ठीक है? Remember the so which one do you think is the molecular end? We have to identify gas X. So can anyone tell me which one is the molecular end out of all these five peaks? And which ones are the fragments?
44 is the molecular
14,
ion.
16.
ठीक है. Well, 44 is definitely the molecular end because that's the heaviest. So that means that's the largest piece. That means it did not break down. It's the whole molecule that's actually getting detected. And all of these are fragments. That the big molecule over here, which is 44, it broke down into tinier pieces and resulted in smaller molecules. Okay, just like this. That you had a big molecule, which is being detected at 60, and then you had all these tiny fragments that would always have a mass of less than 60. And the same happens over here. Uh, then the question said, okay, try and figure out what is each of the fragments and figure out what 44 is. So starting with the smallest over here, what do you think this is? I mean, which particle has a mass of 14 in the periodic table? I mean, the smallest particle is an atom, right? I mean, the molecule would break down into smaller pieces. Eventually, you'll be left with carbon and oxygen and hydrogen atoms. That's it. So the smallest species are usually atoms. So you have 14. 14 is definitely nitrogen. Or when they're talking about fragments, always write +1 over here. Then what's getting detected at 16? Uh,
Oxygen.
so that's definitely oxygen. So what do you think is now you're moving towards bigger fragments. Now bigger fragments are going to be a combination of the original of the smaller atoms, right? So what do you think 28 is? Anyone any idea what 28 is? Sarah, any idea? 28 must be N2 plus 1.
Silicon.
No, not. I mean, see, you have bigger fragments. These bigger fragments can be broken down into even smaller fragments, right? So that could result into in a CO plus 1 fragment. The CO plus 1 could probably be broken down into even tinier fragments, which are your atoms. So, I mean, that's a probability that it might be silicon, right? But the best hunch is that these tinier fragments actually are making up this bigger fragment. Sarah, is this point clear?
Yes, sir.
And then what could be 30? How could you get 30?
NO plus.
ठीक है, so that is NO plus. अब बताओगे finally इस पे आ जाओ. What would be this biggest fragment? I mean, remember all of these are combining. I mean, look over here. That tiny atoms combine to form bigger fragments, even bigger fragments, and even bigger fragments are actually part of this bigger molecule. But we're talking about the whole thing in reverse. Okay, you have a big molecule and it fragments into smaller and smaller pieces, and you have all these tiny particles getting detected. So अब हम reverse में ना we're building it up, starting with the small.
N2.
हाँ, तो क्या फॉर्मूला होगा?
N2O
ठीक है, so इसमें भी
plus.
N2O plus. ठीक है, the plus is necessary because in mass spectroscopy you always detect +1 ions. Now, now the thing is, कि, now the thing is, कि it's going to be. I mean, this is how you're going to detect it. Now, remember these fragments over here. Uh, these smaller particles are always a piece or a part of the bigger molecule over here, the molecular ion, which is over here. I mean, this gas X is basically N2O. Okay, we've been able to figure out what this gas. We've been able to figure out what this gas is. So just remember this bigger molecule over here. These would be tiny pieces of this big molecule. The only reason why N2 exists is because N2 is part of the bigger molecule. During ionization, this big molecule broke down into smaller pieces, and that resulted in an N2 plus ion. I said, let's do another question, which would be slightly more complicated. I said, now they're saying that there's a molecule which is SiXCl Y and OZ. That's the molecule. That's it. And they're saying that there are no isotopes. I mean, Cl doesn't have. I mean, Cl is 35. I mean, this molecule Cl is 35. So, I mean, there is no variation. जो पहले हमने पढ़ा है ना, there is no variation. Well, there would be a M plus 2, M plus 1, M plus 4 peaks, right? I mean, there's no variation in the isotopes. Cl is always 35. Si is 28. And they've said that oxygen is 16. So that is fixed. Silicon is 28, Cl is 35, and oxygen is 16. And this is Z. Z means you're not sure what this is, how many oxygen it has, and you're being asked to draw the structure of this molecule based on this mass spectroscopy, which is you're detecting something at 133, then again you're detecting something at 147. The one एक second. 149. So then you're detecting something at let me use a calculator just a second. अच्छा 149 पे डिटेक्शन है 149 plus अच्छा फिर अगली the next detection is at 247 and after that the detection is at 263 and finally you have a detection at कितने में होगा 393 one second use a calculator it's going to be 263 plus the ठीक है the next detection is at 396 I mean that's a final detection ठीक है so you're getting all these detections at different masses कहीं पे ज्यादा डिटेक्शन हो रही है कहीं पे कम हो रही है randomly ठीक है remember fragmentation they I mean they relative abundance has no ratio well you don't know how the molecule is going to break and it's not going to break every time in the same way अच्छा so this is the mass spectroscopy and they've said that it contains silicon chlorine and oxygen and they're asking draw the complete structure of this molecule showing all bonds एक एक bond show करने and you have to figure out somehow figure out what the structure is. So you're going to draw the complete structure. As a first thing, सबसे smallest से start करो. Try and figure out what this is. 133. I mean, you know, okay, the original molecule is silicon, chlorine, and oxygen. So what could 133 be? I mean, what combination of silicon? I mean, what is that fragment that is going to be 133, which would have a mass of 133? And what combination of silicon, chlorine, oxygen can give you 133? And you're not even sure whether all three elements would be a part. I mean, because this is the tiniest fragment, so it might break into pieces. So you're not even sure if all three would be part of this. But 133, try and figure out what 133 is. Calculator will try some combinations of silicon, chlorine, and oxygen and see if you get 133. Abu Rera कर रहे हो?
सर ये क्या करना है इसमें?
वो बाकी कहे मैं इसको तो समझा दूं मैं हमने ये किया था कि मैस स्पेक्ट्रोस्कोपी तो क्लियर है ना मॉलिक्यूलर आयन होता था एक वो डिटेक्ट होता था उसकी MR60 है ठीक है उसमें चेंजेस क्या आती थी आइसोटोप्स की वजह से आती थी चेंजेस अब ये क्लियर है
यस सर.
फिर हमने ये किया था कि जो मॉलिक्यूलर आयन होता है ना वो आयनाइजेशन के दौरान ना इट आल्सो ब्रेक्स डाउन इनटू स्मॉलर पीसेस एंड स्मॉल fragments are produced मतलब इस पूरे मॉलिक्यूल का ना it could break at any point into small pieces OH टूट के अलग हो गया CO टूट के अलग हो गया CH3 CH2 मतलब anything that breaks away तो you get all these tiny fragments getting detected इनकी masses कम होती है क्लियर है ये भी
यस.
अच्छा तो अब हम ये करें fragmentations पढ़ रहे हैं कि what happens in fragmentation is कि जो tiny pieces है ना they could be put together like a puzzle and you can figure out the original molecule जैसा हमने यहाँ पे किया था कि अगर आपको ओरिजिनल मॉलिक्यूल नहीं पता आप इधर से स्टार्ट करो सबसे टाइनीस्ट पीस से 14 है तो इसका मतलब नाइट्रोजन होगा 16 है तो ऑक्सीजन होगा अब थोड़ा बड़ा पीस आ गया फ्रैगमेंट तो 28 क्या होगा दो नाइट्रोजन कंबाइंड होंगे 30 क्या होगा एन और ओ कंबाइंड होंगे फिर 44 क्या होगा दिस वुड बी द बिगेस्ट द मॉलिक्यूलर आयन क्लियर है ये बात
अच्छा.
तो अब वो कह रहे
समझ लगा.
अच्छा अब वो कह रहे क्वेश्चन के अंदर कि देयर सिलिकॉन क्लोरीन एंड ऑक्सीजन तो व्हाट यू हैव टू फिगर आउट इज कि you have to figure out what उससे क्या draw the complete structure 396 figure out करना है कि ये क्या है molecule है क्या स्टार्ट आप 133 से करोगे, पहले आप फिगर आउट करोगे सबसे छोटा फ्रैगमेंट क्या है, उसके बाद उससे थोड़े बड़े फ्रैगमेंट।
133, we add 3 chlorine, 35 plus 35 plus 35 and plus 28.
Okay, so it's silicon with 3.
3 chlor.
So it's SiCl3 plus 1. I mean, the whole thing would be plus 1, right? So that's the fragment that is produced. That's the smallest fragment. So now it would be very easy. Try and figure out this slightly bigger fragment. What's 149 then? Like, what's the difference between 133 and 149?
Oxygen.
Oxygen.
तो इसका मतलब है कि I mean the same fragment if you just add an oxygen, so you'll have a slightly bigger fragment, right? Which would be 149. So now similarly figure out what 247 is. Like 247 is going to be an even bigger fragment. This tiny fragment will, I mean, grow this into a much bigger fragment. What's the difference between 149 and 247? I think it's 98, right? So 247 would be a bigger piece, but with this 98 added to it. I mean, what is that 98 that you should have? Well, 98 must be easy. I mean, you figured out 133. What is 98? 98 is very similar to 133. सारा
Sir, 2 chlorine and 1 silicon.
ठीक है, तो 2 chlorine and 1 Cl. तो इसका मतलब है इससे बड़ा जो चंक होगा ना, that would be this thing. 1 silicon and 2 Cls, ठीक है, और इस पूरे के ऊपर +1 चार्ज होगा. अच्छा, 263 क्या होगा? That's 247 और 263 में क्या फर्क है?
Oxygen.
ठीक है, तो वो there is the difference of 1 oxygen. और फिर एंड में 263 और 396, that's again a difference of 133. So that is again Si. So that's again SiCl3. क्लियर है? तो इसका मतलब है ओरिजिनल मॉलिक्यूल वो जो 396 है ना, that's this thing. इसी से all those pieces were formed. Okay, 133 was this piece breaking off, 149 was this piece, 98 was up till this point, okay, this chunk, 247 was this thing, and so on. So is this clear? Okay, you figured out the original molecule. You clear है?
Yes, sir.
Yes, sir.
So you'll get questions like these, and the fragments can help you identify. फिर इस तरह you might get questions like these. For example, they might ask you, okay, uh, what particle would be detected, or what peak would you get or let's say what would be the difference in mass spectroscopy so what would be the difference in mass spectroscopy of cyclopropane and propene? मेरे ख्याल से if my memory serves right, that was the question. Now cyclopropane is, both of them have the same formula. It's C3H6. This one also has C3H6. That means that the molecular ion is identical. Because mass spectroscopy does not detect structures; it basically detects masses. So both of them have different structures, but they have the same mass. Cyclopropene would be this thing. And cyclo and propene would be this thing. I say, and remember, okay, the mass spectroscopy cannot identify the structures, the difference in structures. It can identify the difference in masses. So, what do you think? What type of fragment would be formed in one that is not possible and cannot be formed in the other? Like, किस mass के ऊपर? For example, let's say I get a fragment of CH2 plus 1 in my detection, yani at the mass number of 14. Is it possible to get the same fragment in the other molecule as well, or having the same mass? Is that possible?
No.
Nikki, why is that not possible? What if this CH2 breaks off? What fragment would you get? Sarah, is this point clear?
Yes, sir.
I mean, this fragment could be obtained in the other one as well. So you would get a detection at 14 in the first one. You would also get a detection at 14 in the second one. ठीक है? अब वो clear है?
Yes, sir.
तो मुझे बताओ कि difference क्या होगा? What would be the difference?
In the second one, CH2 is breaking off, right? Not only one CH.
किसमें ये वाला या ये वाला?
दूसरा वाला.
I mean, कोई भी चीज break off हो सकती है, ठीक है? It could be anything. As long as it's part of the structure. I mean, one CH could also break off. क्योंकि ionization हो रही है ना, ionization में the molecule could break down in any number of ways. So you might get a detection at CH plus. I mean, this particle would be detected. This would have a mass of 13, but CH is also possible over here as well. Okay, this C and H would break off during ionization, and it would be detected, and it would also have a mass of 13. ये clear है?
जी, sir. Also, sir, can we do more questions? जैसे एक पहले किया, that one was hard.
हाँ, नहीं वो कर लेते हैं. इसका पहले मुझे बताओ कि what fragment could be produced in one molecule that would not be possible in the other one?
Say double bond.
C double bond.
नहीं, I mean you're talking about this piece breaking off.
Yes.
अच्छा, remember कि mass spectroscopy जो है ना, I mean remember mass spectroscopy when you're getting this image. मतलब उसके अंदर you don't know कि whether there's a double bond or not. ठीक है, उसके अंदर the only difference is the mass. ठीक है, mass spectroscopy only detects masses, particles having different masses. उस पार्टिकल के अंदर क्या है, mass spectroscopy को नहीं पता, मतलब it doesn't know कि what it contains. अच्छा, what is the mass of this particle? The mass of this particle is 2 carbons and 3 hydrogens.
27.
2 carbons and 3 hydrogens, so that is 27. Will you get any direction at 27 over here? 2 carbons and 3 hydrogens. So let's say this piece breaks off. What would it be? C2H3 plus 1, and this is also 27. So मसला कि there's going to be a detection at 27 at mass 27 in the first one and also in the second one. So that would not be able to differentiate. I mean, you wouldn't be able to.
बाकी जो CH3 है
हाँ.
15 इधर नहीं होगा.
अच्छा, CH3 might break off, or CH3 plus 1 banega, and this will have a mass of 15. So you would be getting a detection at 15. You'll be detecting a particle that has a mass of 15. यहाँ पे in the other one जो मर्जी कर लो, you would not get a particle that has a mass of 15. I mean, try and break any piece from this original molecule. It's not going to become 15. Okay, let's say, I mean, this is CH2, so that is 14. इसको थोड़ा सा बड़ा करोगे तो it would be साथ वाला C भी बीच में आ जाएगा, तो 14 plus 12 that would become 26. 15 नहीं बनेगा. There's no way कि a piece of this molecule could break off and it will have mass of 15. So the difference in mass spectroscopy would be कि you would be detecting something which has a mass of 15 over here, but over here you would never be detecting a mass of 15 in this molecule. Is this clear to everyone?
Yes, sir.
Yes, sir.
अच्छा, फिर there could be another thing that would be detected over here, which is C2H5 plus 1. I think. Give me 1 second. C2. So there's going to be another thing that would be, well, the 15 is 1. But there is definitely another particle that would be detected over here that would not be possible in the other one. 29, just a second. Is 29 possible over here? Like if I go for a bigger piece, what would be the mass? 2 carbons and 4 hydrogens. Uh, 2 carbons and 4 hydrogens is also possible over here. Okay, so they will have the same mass. So that is definitely not correct. और क्या हो सकता है? It's well, CH2. Any other particle, any other mass that you come up for a particle that would be detected over here would also be detected over here as well. But that fragment would also exist over here. So I think CH3 is the only differentiating point. Okay, दोनों की mass spectroscopy, the difference would be that there would be a detection at 15 in this one, but not in this one. So is this clear? You have a question. Abu, clear है? Sarah, Aisha?
Yes, sir.
Is this
Yes,
clear?
sir.
Yes, sir.
अच्छा बस ठीक है. I mean, this is all about mass spectroscopy. So we'll obviously do past papers with it. Remember mass spectroscopy के जो questions है ना, they mostly linked with NMR. Uh, so we'll do past paper questions in the next class. But the thing is कि mass spectroscopy only gives very limited information. कि you might get some information about the structure from its fragments, but not always. ठीक है, that's वो बस I mean, it would be a partial information. ठीक है, it would be very hard to actually figure out the shape of the structure of the molecule by just looking at the mass spectroscopy. You might get things right, but in most cases, if it's a bigger molecule and it's a complicated molecule, the fragments, it's like a jigsaw puzzle. Like picking up the smaller pieces, trying to make the big molecule over here. So the bigger the molecule, the more difficult it's going to be, and at times it would be impossible. So mass spectroscopy gives you some information by looking at the structure of the molecule. जैसे इस वाले में you figure out के there is no peak at 15 over here. That is an indication that there is no CH3 in the structure. So but there would be tiny hints about the structure by just looking at the mass spectroscopy. The best information that a mass spectroscopy gives is the number of carbon atoms and the number of chlorines and the number of bromides. So next class में continue करते हैं. Next class important होगी. We'll be doing NMR in that, which is also linked to mass spectroscopy. I mean, it's completely different from mass spectroscopy, but since it's an analytical technique, when you look at a molecule, you don't depend on one technique, but you try to get information about the molecule from different methods. ठीक है? And then you try to figure out what the molecule looks like, what would be the structure of the molecule. So one technique is usually not enough. One technique doesn't really give you enough information that you would be able to tell everything about the molecule. चलिए कंटिन्यू करते हैं नेक्स्ट क्लास में, ठीक है?
ओके सर।
ओके, टेक केयर, अल्लाह हाफिज़।
Allah Hafiz.
अल्लाह हाफिज़।